All right. The other part of compound inequalities is combining inequalities using the and. And there's a distinction to be made between and inequalities and or inequalities. When we talk about and inequalities, we mean and inequalities where the solution actually has to be true for both constraints. And that means that our answer is going to include stuff that is true for both x is greater than, in this case, x is greater than -4 and less than or equal to 6. So we're going to start by graphing both of those on the same number line, but separately. We have an open circle at, we'll make that -4, and we'll make this +6. Greater than means go to the right. Less than or equal to means we fill it in and go to the left. Now, when we think about the word and, in this context, it actually means that we're going to be constrained by having the answer has to be true for both things at the same time. So when we look at this particular number line, the area of that number line that is true for both is quite simply the area where the two lines are crossing each other. So this kind of central area where there's the line drawn on top of the other line. So that means the final solution is just a combination of those two things. We just put the 6 here and the -4 here, and the area where those are crossing over each other is that little line in the middle. So we've combined these two lines that cross over each other using the word and, very different from using the word or. Over here, if we start by graphing this to the left, so we have -2, since it's great or less than or equal to, we fill in that dot. We have a line going to the left, and this one is greater than, so we have a line going to the right. Now, when we look at this, if you're being asked what is a number that is less than or equal to -2 and greater than 3, there is actually no such number that is less than or equal to -2 and greater than 3. We can also notice this by noticing that neither of these lines cross each other. So our final answer, it's actually kind of impossible to graph on the number line because there is no number that would fit both of those at the same time. So this is the kind of answer that gives us no solution. Again, a very different solution from when we have an or statement. The final kind of way to combine these, if we have two lines that both go the same direction, so we'll start with the x is less than or equal to +6. We put a 6 here, fill that one in, go to the left, and we have another one at 1. It's not -1, it's +1, and that one goes to the left as well. Both of these are less. In this case, we are going to try to figure out which part of this line is going to be true for both. So again, we want to look at this and we want to figure out where are they crossing. Well, they don't cross here. There's only one line there, but they do cross right here. So if we put the line there, and we essentially just copy down that left line, not filling it in, that's going to be the final answer, because that is the place where that is true for both of them at the same time. So when we're solving these, it's just a little bit more complicated. Instead of, just being able to graph something, all I need to do now is just solve this thing for the variable. This one on the left, x divided by 5 is greater than or equal to -1. Well, for that one, I know that I need to start by multiplying by 5 on both sides. If x is being divided by 5, the opposite of that is multiplication. So I multiply by 5, it cancels the 5 here, gives us x, and I multiply -1 times 5, carry down the inequality. So I have -1 times 5 is -5. And here, -10x is greater than -30. Well, that means that I have to divide this by -10 to get rid of that, and divide by -10 here. Remember, because I'm dividing by a negative, I need to flip the inequality. So x is going to be less than +3 in this case. So when I graph this, draw the line, we have a -5 and a 3. And it's going to be greater than this one, greater than or equal to, that is. So I fill that in. And less than this number. So This is the kind of example where I have two lines crossing. That means that I have to find the area that is true for both, and that means that our final answer is the area between them, because that's the area where they cross. And -5, open circle, closed. Got to copy those down exactly, and we have the line connecting them. So that's one of the kinds of examples. Now, if we go to a different kind of example, something fairly similar. Again, we have another thing where, or another variable being divided by 5. So the exact same thing happens here. We're going to multiply by 5 to get rid of that, both sides. Cancels. So you have p is greater than 1 times 5 is 5. And here we have p minus 1 is less than -11. So we're going to add 1 to both sides. So p is less than -10. So make a number line, not exactly a straight one, but we made a number line. We put a -10 on there, and we put a +5. It is greater than +5 and less than -10. And we're combining these with and, which means that the final answer is no solution, because these two lines don't cross each other, and when you're trying to combine using and, we're trying to figure out what part of this number line is where the two parts is crossing. And that is everything. So, we're done.